As a surprising number of people still believe that we never landed on the moon, the question lies at the heart of one of the greatest conspiracy theories of all time. This is the story of how a handful of bold claims met real-world evidence. A debate born in an era of global suspicion, political mistrust, and a growing wave of fake news. Some voices argue the entire Apollo program was a fabrication. Others insist the idea it could be faked is insane. The challenge is simple. Put the most viral claims to the test and see what survives. The stakes were massive. In 1969, the world watched as Apollo 11 launched. Astronomer Sir Patrick Moore called it one of the most exciting and tense moments in human history. Amateur radio enthusiasts tuned in and even picked up the astronauts' conversations from the lunar surface. At Jodrell Bank near Manchester, a student used the observatory's gear for fun and heard the Eagle descend. Then came the words that froze the planet. Tranquility base here. The Eagle has landed. But even back then, seeds of doubt were planted. A former technical publications head at Rocketdyne, Bill Kaysing, questioned the program's competence and claimed the astronauts were never in the command capsule at launch. He even alleged attempts on his life. Magazine publisher Marcus Allen called Apollo a complete fabrication. Some pointed to Stanley Kubrick. Others confronted astronauts face to face. In 2002, when a conspiracy theorist accused Buzz Aldrin, tempers flared and a punch made headlines, fueling a new generation primed by the internet. So let the tests begin. First, the photos. NASA put every lunar surface image online. Some are bad. Some are incredible. Conspiracy theorists focus on the best ones and say they are too good. They point to shadows that do not look parallel and claim multiple light sources. Physicists and photographers answer with perspective. A single sun can still create converging lines in a wide-angle view. Rugged terrain can distort shadow angles. And something else is at work. Light bounces off the bright lunar surface, off gleaming spacesuits, and especially off the reflective skin of the lunar module. That backlight can fill shadows and make an astronaut look lit from the front, even when the sun is behind. Next, the stars. Critics say there are no stars in the sky in any Apollo photo. The answer is exposure. Cameras set for a bright gray landscape will not register faint starlight. In a field test using the same type of camera and film settings, night sky stars did not show up either. Even Apollo astronauts explained it. On the daylight side of the moon, eyes and lenses are adapted to a bright foreground. The stars are there, but the settings wash them out. Now the movement. The famous lunar hop looks slow and floaty. The claim is that it is just slow-motion footage with hidden wires. But the suits were heavy, and the center of mass sat higher than usual. That made movement different. Astronauts learned to adapt. NASA trained with parabolic flight to sample reduced gravity for short bursts. The footage shows unique momentum and balance shifts that match 1/6 gravity. Slow motion alone would not recreate that, without the telltale wire jerkiness critics themselves point out. The flag is a favorite. Why does it seem to wave with no wind on the moon? The answer sits in the hardware. A horizontal rod kept the nylon flag extended. When the pole twisted into the hard ground, the springy aluminum and the fabric oscillated. With no air to dampen those vibrations, the motion continued for a while, then settled. There is also the glow. A nylon flag lets light pass through, so even on what looks like the shadow side, it can still appear bright. What about the landing itself? Should a powerful engine blast a crater? Footage and photos show dust blown radially and a slight depression under the engine bell. Apollo throttled down dramatically before touchdown and cut off just before landing. That left disturbed dust, not a giant hole. Close-up images show subtle soil disturbance around the pads and rays of swept surface beneath the descent stage. Then there is the tech. Could 1960s computers do it? Former NASA engineers explained that those systems were primitive by today's standards, but adequate for the job. The onboard computers did not need to browse files or process images. Most heavy number crunching happened at mission control, and the guidance software handled exactly what it needed. There were risks. Training even included a prototype lander that Armstrong had to eject from when it went out of control. But risk does not equal impossible. What about the cameras and those pressurized gloves? Apollo used modified Hasselblad units with giant shutter releases, paddle grips on the Zeiss lenses, and preset focus stops for near, medium, far, and infinity. They were chest-mounted, so astronauts aimed by feel. Crews practiced constantly, taking the cameras home and shooting everything to build muscle memory. NASA's photo instructors drilled a simple truth. These images were their key to immortality, so make every frame count. Now the heavy hitter: radiation. The Van Allen belts surround Earth with zones of trapped particles. Apollo trajectories were designed to slip through the thinner regions quickly, avoiding the worst areas. Solar storms were monitored by scientists to steer clear of dangerous periods. If a burst had occurred, crews could reorient to use fuel, water, and oxygen tanks for extra shielding or launch off the surface before the worst arrived. After Apollo 16, a powerful solar flare hit the moon while no one was there. Conspiracy theorists point to newer programs discussing radiation protection and claim that proves Apollo never happened. Engineers counter that every mission has different safety margins and designs, and Apollo made schedule-driven risk trade-offs. There is physical evidence, too. Apollo brought back 382 kilograms of lunar soil and rock. In California, geologists study tiny glass spherules formed by meteor impacts. These samples show cosmic radiation signatures not found in Earth rocks because our atmosphere shields them. Their ages clock in at around 3.9 billion years, consistent with an ancient lunar surface. Researchers state with confidence that these materials came from the moon. And then there is what was left behind. Apollo crews placed corner reflectors on the lunar surface. Fire a laser from Earth at those reflectors and the beam bounces straight back. That lets scientists measure the Earth-Moon distance to centimeters. Yes, people bounced lasers off the moon even before Apollo, but the reflectors make the signal sharper and far more precise. Anyone with a big telescope and a powerful laser can do it. No permission needed. One more thing. If this was a hoax, the Soviet Union was listening. They had the capability to track, to eavesdrop, and to embarrass the United States at the height of the space race. Silence from rivals speaks loudly. In the end, experts argue that faking everything and keeping tens of thousands of people quiet for decades would be harder than building the rockets and going. 50 years later, skepticism still follows every giant leap. The question remains: in a world of noise and doubt, which is harder to believe, that hundreds of thousands of people pulled off the greatest cover-up in history for half a century, or that humanity really did take those first steps on the moon?